Good day, everyone. I'm Vikas Behera. I lead the data and analytics team in FSI PACE. We have developed a reference solution called DAIVI for data, analytics, AI, and visualization. This solution is based on the prototypes we have developed for financial services customers. Today, we would like to share the DAIVI solution with you. FSI customers are very excited about the next generation Sagemaker platform that enables data, analytics, and AI. I'll touch upon 5 specific ways customers plan to leverage the Sagemaker platform. First, Iceberg. Customers are excited about the Iceberg standard and how they can benefit from it. They're very excited that the next-gen Sagemaker platform anchors on Iceberg. I'm talking to a lot of FSI customers who are interested in learning about our current and future support for Iceberg. They're not only excited about its capabilities as a transaction data lake with support for time travel and schema evolution, but also as an interoperability standard. Second one is integrated data access. Customers are excited how Sagemaker Lakehouse will give them integrated data access to data lakes, data warehouse, databases, and third-party data sources and applications. They're excited about the ability to integrate data and data catalogs from multiple vendors. They like how zero ETL ingestion, replication, and federation is going to help them create an integrated data platform. Third is data governance. They like how Sagemaker Catalog allows them to discover data assets, assess data quality, visualize their data lineage, and distribute them across the organization through a data mesh architecture. Fourth is unified experience. They like how Sagemaker Unified Studio allows them to deliver a project-based experience to the rest of the organization. The analysts no longer need to access AWS Management Console. They like the Unified Studio portal experience. Fifth is data analytics and AI. Customers like the fact that Sagemaker provides the ability to undertake end-to-end processing incorporating data, analytics, and AI. Customers are very excited to explore the implication of the next-gen Sagemaker platform for their organization. Essentially, the customers are looking to create Iceberg data lakes and adopt the next-gen Sagemaker platform, including Sagemaker Unified Studio, Sagemaker Lakehouse, Sagemaker Catalog, and Sagemaker Zero ETL integration. They're asking for Terraform infrastructure as code and Python scripts to automate this. This is the mental model we are using to help customers adopt Sagemaker platform. Customers like that they can create domains and domain units to reflect their organization structure. They like that they can provision projects that gives users access to data, compute, and tools they need to do their job. There are 3 personas we focus on: infrastructure engineers, data engineers, and data analysts. We have created Terraform codebase to allow infrastructure engineers to create Sagemaker domains and projects, add members to the projects, and grant them access to data and compute they need. We have created Terraform code to help data engineers implement batch and streaming pipelines to create data lakes. Our goal is to help infrastructure engineers and data engineers to deliver a seamless experience to the data analyst. We leverage assets from various customer engagements to create the solution vision for DAIVI. In Q1, we released the functionalities covered by boxes 1 to 6 that include Identity Center, Iceberg Tables, Sagemaker Unified Studio, Sagemaker Catalog, DataZone, data pipelines, and visualization. In Q2, we'll explore the power of Zero ETL integration to integrate AWS data sources, external data sources, and third-party apps, in addition to providing Sagemaker Ops support. Plus, we will be adding modules for ML, AI, and Gen AI. Let us go through each of the modules. In Identity Center module, we provide Terraform code to provision account level and organization level Identity Center with support for adding users and groups and configuring permission sets and IAM mapping. In Iceberg module, we provide Terraform code to provision Iceberg data lakes, both using S3 standard bucket and S3 table buckets. In SageMaker Unified Studio module, we provide Terraform code to provision SageMaker domains, provision SageMaker projects, add members to projects, configure Lakehouse, and configure compute. In SageMaker Catalog module, we provide support for adding standard assets, custom assets, data lineage, both standard and custom, data quality, and data mesh. In DataZone module, we provide support for adding standard assets, custom blueprints, data lineage, data quality, and data mesh. In data pipeline and visualization module, we provide Terraform code to implement glue batch pipelines to populate data lakes, analyze using Athena, and visualize using Quicksight. We released the first 6 modules on March 31st, end of Q1, so that field teams can accelerate Iceberg and SageMaker adoption and accelerate revenue capture. In Q2, our immediate focus is to add Terraform code and Python code for a zero ETL integration. We are currently focused on Snowflake and Databricks integration. This is the architecture of the Davyy solution we have developed. At the heart of the solution are the data lakes, both Hive and Iceberg. The data lakes are populated with data from batch pipelines and streaming pipelines. Once the data is in the data lake, you can analyze the data using Athena and visualize the data using Quicksight. It also creates a SageMaker domain and 2 projects, one for producer and one for consumer, and imports the data lake into SageMaker Lakehouse, creates data catalogs, and demonstrates data quality, data lineage, and data mesh architecture. As of March 31st, we have implemented the batch data pipeline based on the work we did for customer. We have code base for streaming pipelines using Glue and streaming pipeline using Flink for other customers. We will add them to the code base in Q2. This is the URL for the Davyy repo. Thank you for watching an introduction to Davyy solution. We'll now give you a demo of the solution. We developed the solution for a customer who wanted to create an Iceberg data lake for cost analytics. We have implemented a batch data pipeline to receive data from 3 sources. 1, AWS cost and users reports. 2, AWS S3 inventory reports. 3, Splunk and operational data, and store them in Hive and Iceberg data lakes. Once the data is in the data lakes, the user can analyze the data using Athena and visualize the data using Quicksight. It also creates a SageMaker domain and 2 projects, one for producer and one for consumer, and imports the data lakes into SageMaker Lakehouse, creates data catalogs, and demonstrates data quality, data lineage, and data mesh architecture. Let us take a look at the cost and users data lake. We have implemented the data lake in 4 different ways. First scenario is a Hive data lake on a standard S3 bucket with a static schema. Second scenario is an Iceberg data lake on standard S3 bucket with a static schema. Third scenario is an Iceberg data lake on S3 table bucket with a static schema. And the fourth scenario is an Iceberg data lake on standard S3 bucket with a dynamic schema. The number of columns in a cost and users report changes every day depending on the number of AWS services being used. The solution inspects the columns in the cost and users report using a crawler and updates the schema of the Iceberg table dynamically. Similar to cost and users data lake, we developed a data lake to capture S3 inventory data and implemented all the 4 scenarios. Based on customer requests, we also implemented a data lake for capturing operational data from a Splunk application. With this background, now let us take a look at the demo of the solution we have developed. We have deployed the Davyy solution to an AWS account. Now let us take a look at the solution that we have deployed. If you come to S3 console and search for billing, you will see all the buckets that are created for the billing scenario.
If you click on Billing Hive Primary, you will see the S3 bucket that is created to store billing data in using Hive scenario. And this is what we have always seen in the past. If you go to S3 console again and search for billing and search for this billing Iceberg primary, this is where we are storing data and metadata for Iceberg table. You'll see there are two folders, static and dynamic. If you go to the static folder, you will see there's a data folder and metadata folder. The difference between Hive and Iceberg data lakes is that in Iceberg format, you store data and metadata for your data. So this is where we are storing data for the Iceberg table in Pocket format. And if you go to metadata, you will see the metadata associated with Iceberg in the metadata folder. So the data and metadata together comprises your Iceberg data lake in static scenario. If you go to dynamic, you see the similar data and metadata structure, and this is where we are storing data for the Iceberg data lake for the dynamic scenario. So we've shown you the Hive scenario, we've shown you the Iceberg scenario for static and dynamic data lakes for billing using Iceberg on standard S3 bucket. Now let's take a look at S3 table bucket. S3 table bucket is a new kind of bucket that is supported by AWS to make it easy for you to create your Iceberg data lakes on S3. It's a managed experience. If you see here, you will see a bucket for billing, a bucket for inventory, a bucket for Splunk. If you go to billing, you will see there is a table called billing, and in an instance Davyy. So we showed you how you are storing data for your Hive data lake and Iceberg data lake on standard S3 bucket and also on S3 table bucket. If you go to Glue and you click on databases, you'll see that there is a database for billing, a database for inventory, and database for Splunk. If you click on billing, you will see there are three tables, one for the Hive scenario, one for Iceberg static, and one for Iceberg dynamic. You can query this data from Athena. If you go to Athena, you will see there are four catalogs created. The first one is the standard S3 the standard Glue catalog that is created for all tables that are using standard S3 buckets. And these are the different catalogs created for S3 table buckets. So anytime you create S3 table bucket, you create a catalog called S3 table tables catalog slash the bucket name. Now let us start looking at the data lakes you have created in the S3 standard bucket. If you click on Billing Hive, you see the data that is stored in your Hive table on S3 standard bucket. And if you click on the preview table for Iceberg static, you'll see the records stored for the static scenario. If you click on Iceberg Dynamic, you'll see the records for the dynamic scenario. So this is where we are seeing data either stored in Hive format or Iceberg format in a standard S3 bucket. Now let us take a look at a S3 table bucket. So in this Davyy OS for billing S3 bucket, you see a table called billing, and if you do preview, you will see the data for the billing table in the S3 table bucket. So from Athena point of view, your experience querying either a Hive Iceberg table stored in S3 standard bucket or your tables created in S3 table bucket are similar. Now let us take a look at Amazon Sagemaker Next-Gen platform. This is the new service that Amazon announced in last re:Invent that brings your data analytics and AI together. The Sagemaker platform that you're used to using in the past with your ML and AI capabilities is now called Sagemaker AI. And here you can create a domain. So domain is your starting point for your experience in Sagemaker Next-Gen platform. You can create a domain for Amazon Sagemaker, or you can create a domain for Amazon DataZone. We have created Terraform code to help you create either a domain for Sagemaker or DataZone. We'll look at each of them one by one. If you click on corporate, this is the domain that you have created for the Sagemaker scenario where you would see all the configuration for the Sagemaker scenario created automatically. If you go to blueprint, you will see all the blueprints enabled for the domain. If you go to project profiles, you will see the 3 project profiles that are created leveraging the blueprints. This is all automated through Terraform. So in Terraform, we create a domain, we enable the blueprints, we create project profiles. So you reverse engineered what happens when you click on create domain in SageMaker console. We have reverse engineered and provisioned everything for you and packaged everything is a Terraform module. Now, if you click on Open Unified Studio, you will log into the Unified Studio console. And you'll see that this Unified Studio console is different from the management console. So we are giving your data analyst a different experience where they don't have to log in to AWS Management Console and they can directly go to the portal that is designed for them. So this gives your data analyst a seamless experience going forward. And within this domain, we have created 2 projects. As you mentioned, we have created a project for a producer and a project for a consumer, where a producer brings people together through a project experience, allowing them to create and curate assets and publish them that the consumer project will use. And we'll demonstrate the details in this demo. If you go to producer, you will see on the left side uh, a tab, a link for data. Then there's another menu item for compute, and another menu item for member. So a project is a managed experience where you, as the experience provider in your organization, create a project and bring people together to that project. For example, if there is a team that wants to do risk analytics, you create a risk project and bring all the risk analysts to that project so they get access to this project. And in data folder, you give them access to the data they need to see. In this case, you've got this Lakehouse architecture where we give them access to the data they need. So this is your Lakehouse, then you've got Redshift, then you've got S3. We give you access to the data no matter where they live. And compute section, if you go here, you will see that you can provision different computes. So in data warehouse, we have pre-provisioned a Redshift serverless cluster. In data processing, we have pre-provisioned a EMR serverless cluster. So as a project provider, as an infrastructure provider, you have the opportunity to decide what kind of compute you want to provide to your project team, what compute they need to do their job, and you provide that specific compute to them. If you go back to data, and let's explore this further. So this is where we have enabled the data lakes that we have created earlier. We've given this project access to those data lakes. And the way you do this is every project is associated with a role, and you give that role access to this specific data lakes through lake formation. And as I showed you earlier, you were able to see the billing inventory and Splunk created on standard S3 bucket using Athena. And you are seeing billing inventory and Splunk on S3 table bucket, and you see all of that here. If you click on billing and you click on tables, you'll see the 3 tables that I shown you earlier. If you click on this and you want to query with Athena, and this is where the interesting thing happens is this clear segregation between data and compute. Here, the data that you have available in the data lake, you can query them, you can analyze them either from Athena or Redshift or from EMR through Jupyter Lab, Jupyter Notebooks. Let's start with the Athena experience. If you go here and click Query with Athena, it will query the first 10 records using Athena engine. So your data is in your data lake and you're querying it through the Athena engine. You can also query this using the Redshift engine. So we have created a Redshift serverless cluster for your users, and it queries and gives you the first 10 records for the data lake. And you would see this experience for, you can go to Hive, you can look at the static table, you can query against it. You can query against your dynamic Iceberg table. So the way from Athena you're able to query your Hive and Iceberg tables in a uniform fashion, you can do the same thing here. And you can do the same thing for your tables created in an S3 table bucket. You come here, select your table, and you query against it using Athena. It runs the query and gives you the result. So here we have shown you how you can query against your data stored in Hive or Iceberg Data Lake using S3 standard bucket, or your data Iceberg table in S3 table bucket. All of that can be accessible or queryable, analyzed uh, from the Sagemaker Unified Studio console. In addition to the Athena and Redshift, let me show you the Jupyter Lab experience. So this is where I've created a simple notebook with one line here. I'm saying Spark SQL, run a SQL query against the Hive table. And I chose the PySpark as my engine, and I'm using Yamashaula's cluster to run the query against. So this one line query using EMR gives me this result when it queries against that particular Hive table. So what we have shown you here is ability to query your data either using Athena, Redshift, or EMR. So the compute that you provision in a project depends on the compute that your project team needs to do their job. Some project team just needs Athena to do exploratory analysis. Some project teams may need Redshift serverless cluster to do detailed analytic queries, and some teams may need to write Jupyter notebooks and use GMR to run those analytic jobs. So we provide you all that functionalities. Now that we have covered the Lakehouse experience using Sagemaker Unified Studio, now let's move our attention to the Sagemaker Catalog. So in Sagemaker Catalog, there's a concept called data sources. By selecting data sources, you're able to connect to your data sources and query them. So if I click on Create Data Source and I select Inventory as my data source, and I want to go against a glue data source for inventory, and I select that I want to do import data lineage as I do my query, and I select a database name called inventory. So there is a data lake called inventory. I'm going to load the data source into my catalog. And if I click here next, it asks me to confirm the selections that I have made. Then if I do next, it gives me the two options. Do you want to run this on demand, on schedule? I want to run this on demand. What this means is I want to extract the metadata on demand instead of creating a schedule. But you can create a schedule if you're interested. And then I click on create, where I'm creating a data source connection to my data lake, inventory data lake. And once it is created, you can click on the run button because it's selected manual. I can click on the run button to load the data assets that I have created in the inventory data lake. And this will go and discover the data assets. So this is running as a discovery process. Now it discovered the data assets available in my data lake. But in future, if you have changed your assets, you can come here and click on run again to reload them. So all these assets that are discovered are available in the assets menu. If you go here, you see those three tables available as assets cataloged inside your Sagemaker catalog. Now let's look at inventory Hive. So this is the asset that was exported from the inventory, and this is the schema, and these are the data quality rules. So what we have done is when we created our glue jobs, glue tables, we specified the data quality checks we would like to apply against our inventory data lake. And this is the lineage information you get to see when we loaded the data lake. So if you look here, we are able to demonstrate your lineage information of data coming from an S3 bucket, going through glue transformation, go to another, that is then going to a glue table, and then I'm creating a inventory of that data asset in our inventory. To make it easy, let's edit the name of the data asset. Let's call it inventory Hive. So let's make it a easy to read name here. And now that we have the data asset available, and we looked at the data asset that was discovered. We looked at is data quality and data lineage. Now let's spend a little bit more time diving detail into the lineage.
You can think of Sagemaker Catalog as a repository to store data lineage information that can be accessed through Open Lineage API. We are showing three scenarios. One, AWS native services such as Glue publish data lineage directly to Sagemaker Catalog. Two, third-party products such as Databricks that support Open Lineage standard can publish Open Lineage events. Three, customers want to use Sagemaker Catalog to store lineage for their on-premise assets and on-premise events. Let us think of this on-premise scenario where front office receives an order, middle office transforms it so that back office receives a trade.
Let's take a look at a custom uh, Python program that you've written called Lineage. And here you're creating assets and then you're publishing a lineage event. If I run this job, this is going to create the asset and publish lineage information. And if I go to my producer and if I go to my assets, I will see that I have a order job, order and trade. If I click on trade and if I go to lineage, you will see that it has captured lineage information for the custom scenario where I published two custom assets, order and trade, and publish the lineage information that connects them together. So this is the way you are able to discover your lineage, your assets, and you get to see the asset details and the data quality and data lineage. Now let us move it to the power of data mesh architecture. So in this, as I mentioned, there's a producer project and there's a consumer project. So producer project curates asset and publishes, and consumer project consumes those assets. So if we go to producer, if we go to my assets, so let's look at inventory hive. Let's rename this again to make it a little easy to read. It's inventory. So if you look at my inventory, so at this point, I have the schema of my inventory asset. I've got data quality and data lineage, and I am going to publish this asset so that other organizations can use it. Now, if you see here, you see that using AI, we are able to capture and generate metadata. If I click on accept all, I'm going to accept the recommendation that AI has provided me for this particular asset. So if I go here, if I go um, to some of this metadata and schema that will be populated with the AI provided information. Now, if I go to publish asset, I'm going to publish this asset to downstream systems. So if you see here, you see, are you sure you want to publish the asset inventory Hive? I click on publish asset, and now you see this asset status, it changes publish. So what I did here is I published this inventory Hive asset that other part of the organization can use it. Now let's look at the asset discovery and consumer project. So consumer project is another project. For example, if a producer project is a risk analytic team that is producing risk models, the consumer project could be a portfolio management team that uses those risk models. So if you're in the consumer project, you can go to discover and check catalog. And at this, you will search for the word inventory. And when you do inventory search, it will show you that somebody has produced the inventory hive. And if you want to click on this, you will see that it is produced by a team called producer within the corporate domain. And you get to see the schema details, you get to see the data quality rules, and you get to see the data lineage information. and you like what you see, and then you will click on subscribe. So the consumer project is going to subscribe this asset available. They mention consumer as the project, and they give some region for the subscription, and they issue a request. At this point, the portfolio management team has or consumer team has submitted a request for that inventory Hive data. And if you go to producer project now, you go to subscription request, you will see that the consumer team has asked for the inventory Hive data that you have published, this particular curated asset you have published. You can go to view the request detail to understand who it is, and the requester is Lois in the consumer project, and they want to do is for marketing analysis. At this point, you can either reject or approve. If you approve, you can approve to give them access to the entire data set, or you can approve to give them access to only a set of rows and columns. So keep it simple. You can select full access, and you select approved as your comment, and you click on approve. So at this point, the producer received the request from the consumer who's interested in your asset, and you approved it. And by approval, now if I switch to my consumer project, and I look at my subsequent request, the request that I sent out, and I will see that the inventory Hive request that I had submitted, now it is approved. My subscription is approved, and I should be able to access the inventory Hive. So if I go to data within my consumer project, and if I go to my data catalogs, and if I go to my Glue database, the standard Glue database that comes with a catalog, I see the inventory Hive table here. So this table or this asset was produced by the producer, and because I subscribe to it, I get to see, and I can run a query against it. I can do Redshift analytics against it. I can do EMR analytics against it. So this creates a nice data mesh architecture between producer and consumer. The producer team curates the data assets and produce it, and the consumer teams get to subscribe to it. And once approved, they can use it any way you want. So this allows different business units in your organization to curate and publish assets that other teams in your organization can subscribe to. Now, let us take a look at the next functionality, which is DataZone. As I mentioned, we have created two different domains, one for Sagemaker, one for DataZone. Some customers who haven't greenlisted Sagemaker yet can continue to use DataZone for data governance. If you click on DataZone and say Open Data Portal for DataZone, you are taken into the DataZone project where you can browse the various projects created. So similar to Sagemaker, we have created three projects here. One is a producer project that can produce asset. Second is a consumer project that can consumer asset. And third is a custom project using custom blueprint in DataZone scenario to bring your custom data lakes online that other people can use. You can, once you deploy the solution, you can go to each of the project and get to see the data sources and work with them. So this is your overview of DataZone. Won't go too much detail into that right now. And now let us look at Quicksight. So as I mentioned, we deploy a Quicksight solution, a Quicksight dashboard along with the solution. We automate the process of subscribing to the account. And if you go to dashboard and click on this, so we have created a dashboard or a billing dashboard for Quicksight. So you can see the few reports you have created from billing point of view, and you can see the results. So at this point, we have shown you how you can create your data lake, both Hive and Iceberg on S3 standard bucket or S3 table bucket. How you can see the information in Glue database and Glue tables. You can query them from Athena. You can interact with them from Sagemaker. You can run your, you can add them to your Sagemaker Lakehouse, and you can interact with them. You can do Sagemaker Catalog, data governance, and data mesh architecture. And finally, you can do visualization. Now, this brings the demo to the conclusion. I hope you deploy the solution to your account and get to play with all the functionalities that you have released. Let us take a look at the open source repo. If you go to your browser and enter tinyurl.com/AWS DAIVI, you will come to the open source code repo that we have delivered. If you scroll down, you will see a section called Table of Contents. And at the top of the section, we describe the details of the Davyy solution. Then we describe the management data lake that we have developed. Then we give the detailed instruction on deploying the solution to your account. Then we give you detailed guidance on the solutions that you have developed so that you can explore it in detail. If you scroll down here, you get to see the vision of the solution. You get to the solution architecture. You get to see the detailed components of the solution. And you get to learn about the details of the management data lake and the various data lakes that you've implemented. Finally, when you click on deploying Davyy, we have provided very detailed instructions to deploy the solution to your account. Kindly read the instructions here so that you can deploy the entire solution to your account. And after you deploy the solution, when you clear exploring Davyy, you will get to see the details of the solution that you have developed that you can explore yourself. You can take a look at the billing data lake that you have created and learn more about it. You can click on the domain section to understand what Sagemaker domain you have deployed and get to learn more about it. So this is the overall solution report that you have developed, we have delivered. Kindly deploy to your account, explore it, and give us your feedback. Thank you very much.
Thank you for watching demo of the Davyy solution. We look forward to working with you to accelerate Iceberg and SageMaker adoption in your organization, leveraging the Davyy solution.